GPU Accelerated LLM Inference on AWS EKS, a hands-on guide. This podcast is brought to you by Business Compass LLC. We are an Amazon Web Services advanced consulting partner. We build and migrate workloads to Amazon Cloud. Our website is businesscompassllc.com. Our phone number is 973-638-2228. Our email address is contact@businesscompassllc.us. Introduction. Running open source LLMs on EKS large language models. LLMs, like Mistral 7b, are revolutionizing the field of natural language processing, NLP, with their powerful text generation capabilities. Running these models on Kubernetes, specifically Amazon Elastic Kubernetes Service, EKS, allows for scalable and efficient deployment. This podcast will explore setting up GPU accelerated inference for open source LLMs on AWS EKS. Prerequisites, tech stack and assumptions. Before we dive into the setup, let's outline the prerequisites. AWS account. Ensure you have an AWS account with the necessary permissions. EKS cluster. A running EKS cluster. Carpenter. For efficient node provisioning. Kubectl. Command line tool for interacting with Kubernetes clusters. NVIDIA GPUs. Required for accelerating model inference. Making GPUs accessible to pods, hardware and software configurations. To run GPU-accelerated workloads on EKS, you must ensure your cluster can utilize GPU nodes. This involves both hardware and software configurations. Hardware. Choose the appropriate NVIDIA GPUs based on your model's requirements. Software. Install the necessary drivers and device plugins to expose GPU resources to your Kubernetes pods. GPU requirements. Identifying the right GPU for Mistral 7b. The Mistral 7b model is resource-intensive. Based on its computational demands, consider the following GPUs. NVIDIA Tesla V100, ideal for high performance. NVIDIA A100, offers the best performance for large-scale models. Evaluate your budget and performance needs to select the most suitable GPU. Provisioning GPU nodes with Carpenter. Cost-effective strategies. Carpenter is an open-source node provisioning project that helps scale your Kubernetes cluster efficiently. To provision GPU nodes. Install Carpenter. Follow the official Carpenter installation guide. Configure GPU instances. Define node templates that include GPU instance types, such as P3.2slarge or P4D.24slarge. Exposing GPUs to pods. Installing the NVIDIA K8s device plugin. To make GPUs available to your pods, you need the NVIDIA Kubernetes device plugin. Deploy NVIDIA device plugin. Kubectl apply https://raw.githubuzercontenten.com/nvidia/k8s device plugin v0.9.0/nvidia device plugin.yml. Verify deployment. Ensure the plugin is running and exposing GPU resources. Validating GPU access. A quick test. Validate that your pods can access the GPU. Create a test pod. API version, v1. Kind, pod. Metadata. Name, GPU test. Spec, containers. Name, CUDA container. Image, NVIDIA/CUDA, 10.0 base. Resources, limits. NVIDIA.com/GPU, 1. Command, NVIDIA SMI. Deploy the pod. Kubectl apply fgputest.yaml. Check logs. Kubectl logs gpu test. You should see the output of NVIDIA SMI, confirming GPU access. Deploying the text generation inference server, simple Kubernetes manifests. Deploy the inference server using a Kubernetes manifest. Create deployment manifest. API version, apps/v1. Kind, deployment. Metadata. Name, text gen server. Spec. Replicas, 1. Selector, match labels. App, text gen. Template, metadata. Labels. App, text gen. Spec, containers. Name, text gen. Image, your Docker repo/TextGen server latest. Resources, limits. NVIDIA.com/GPU 1. Ports. Container port 5000. Apply the manifest. Kubectl apply ftextgen server.yaml. Testing the inference server, a basic curl command. Verify the inference server is working by sending a request. Curl x post http:// your server IP greater than 5000 / generate h content type application / JSON d text. Hello, world. Ensure the response contains the generated text, confirming the server's functionality. Bonus: building a local chat client interface with Gradio. For an enhanced user experience, build a local chat client with Gradio. Install Gradio. Pip install Gradio. Create a simple interface. Import Gradio as gr. Def chat text. Hash replace with the endpoint of your inference server. Response equals request.post http:// your server IP greater than 5000 / generate JSON equals text. Text return response.json generated _ text. IFES equals gr.interface fn equals chat. Inputs equals text. Outputs equals text IFES.launch. Conclusion. Deploying GPU-accelerated LLM inference on AWS EKS involves several steps, from selecting the proper GPU to validating the setup and deploying the inference server. Following this podcast, you can efficiently run powerful LLMs like Mistral 7B on your Kubernetes cluster, ensuring scalability and performance. Thank you for listening to our podcast. Please share this podcast, visit our website, and follow our social media links.